So let's talk about a couple of applications that involve our number e and our exponential function right here. And this first one, mostly we're going to give these to you in terms of formulas, although there's some that we will have to develop later. This one is about monthly income in dollars from a new product, and it's given by the function I of t is equal to 8,600 minus 5,500 times e to the negative 0.005t. Now I definitely have to use a calculator for this one, so I'll bring that up as we go. But the question is, if t is in time, in months, since the product was first put on the market, we want to know, first of all, what was the monthly income after the 10th month and the monthly income after the 100th month. So let's work that out. What does that mean? Well, remember, t is our variable representing time in this setup, so we're going to make the substitution for part A by allowing t to equal 10 months. And let's find out what happens. So I, the income at 10 months, is going to equal 8,600 minus 5,500 times e to the negative 0.005 times 10. Now that 10, right, if we multiply a decimal times 10, it simply moves the decimal one place to the right. So in this case, this is really the same thing as saying 8,600 minus 5,500 times e to the negative 0.05. In this case, we move one decimal place to the right. So what will that work out? Well, this is where I'm going to need my calculator. So here's my calculator. I'm using the Windows one. And I want to find out what's going to happen. So what do? I'm going to take 0.05. I want to take the negative of that value. And I'm going to raise e to that power. So it will be inverse e to the x right there. So that's this number right here, right? This is like saying 5,500 times, or sorry, e to the negative 0.05. So we need to multiply this guy times 5,500. So times 5,500. Right? And we're going to subtract this result from 8,600. So it's going to be this result subtracted from, so I'm going to take the negative of it and add that to 8,600 to give me my result. And in this particular case, that turns out to be 3368.23. Well, of course, we want to make that annual income, so this is dollars and cents. So we need to round it to the nearest cent right here. So we'll make it 3368.24. Right? So our income we would expect after 10 months might be $33,368.24. All right. Well, what happens after the 100th month? It's a lot of months, 100 months, right? But let's see what happens after 100 months. What would happen to this particular thing? We'd expect that income to be 8,600, according to this model, minus 5,500 times e to the negative 0.005 times 100 this time. And of course, recognizing the idea that multiplying by a 10 or a factor of 10 here is going to move that decimal over to the right. This is going to be two places, so it would be the same thing as saying 8,600 minus 5,500 times e to the negative 0.5 this time, right? We move that decimal place two places to the right by multiplying by 100. What's going to happen here? Well, again, this is where we need a calculator to kind of help us out. Before we found 33 3368.24. So let's find out what happens here. In this case, we're going to take 0.5, negative 0.5 here, so we negate this. We're going to raise it to the power e to the x. We're going to multiply that result by 5,500. And we're going to negate that and add it to the number 8,600. So we're subtracting it from 8,600. And this time we find that our expected income goes up. This time it goes to 5,264.08. So we would say that our expected income after the 100th month would be $5,264.08 here. Let me see what we can't do about this decimal place right here that just keeps on leaking through on my pen here. 08. There we go. Okay, so now what? What do we say about this? Well, B is asking us, well, what's going to happen as for monthly income as the product approaches, as time increases without bound? What does that mean? Time increases without bound. Well, we think t is going towards infinity, right? How long? What is this actually going to approach? We see that it's gone up. Does that mean it's going to continually go up and go towards infinity? Well, maybe not. Let's try it. And I did this same experiment right here, using the same function, and I did it at 1,000, and I did it at 10,000. And I asked myself, well, what is going to happen? Right? Just keep adding zeros here. What happens to this? Well, remember, this would say 8,600 minus 5,500 times e to the negative 0.005 times 1,000. Right? Well, what is that really? Well, we look at that, we think of that as being 8,600 minus 5,500 times e to the negative 5. And what does that number come to? Well, it comes to 8562, pardon me, 8562. Let me check my numbers right here. 8562. I'm reading my sheet right here in front of me. 8562.94. And if you continue increasing this, what's going to happen? Well, eventually, that term, e to the negative 0.005 t, as t increases towards infinity, right, gets very, very large, remember, this is going to go towards 0. So we've got this number that's getting smaller and smaller as we subtract it from 8,600. So what's got to happen right here is that eventually I of t has to approach 8,600 minus 0, or $8,600. So eventually what would happen over time is that this particular function has a value that approaches $8,600, right? That e to the that 5,500 e to the negative something t approaches 0. There we go. Another application to come.